Okay, we've worked with inequalities with one variable. Today we're going to explore inequalities with two variables, linear inequalities. So as a reminder, you need to remember what the less than and less than and equal to sign are compared to the greater than or the greater than and equal to sign. So I just put those there. Go ahead and put them back in your notes to bring them into your head. Okay, so for number 1, 2, and 3, we're just testing to see if the ordered pair is a solution to an inequality. What that means is that this ordered pair, when you substitute the 3 in for the x and the 2 in for the y, it will make the statement true, the inequality true. So I want you to do this one on your own by plugging them in and seeing if the statement is true at the end. As a reminder, I would read this one out loud as you're doing it, just to make sure that you've got it correct. Pause your video while you're doing it and then check back for the explanation. The biggest trick on these three was really number 1, and sometimes students will just see the 5 and the 5 on either side and go, yep, that's true. But if you read it out loud, it says 5 is greater than 5. Well, that's not true. It doesn't have the equal sign, so it's not true. Okay, so now we're going to actually start working on graphing linear inequalities. And to graph them, I've put together a little chart up here on the right side, because when we're graphing a linear inequality, we'll graph the line the way you already know how to graph the line, except that we're going to have to decide if we're graphing a dotted or a dashed line, or if we're graphing a solid line. You've only just graphed solid lines in the past. Now we also have the option of graphing a dotted line. And then once the line is graphed, we have to decide, are we shading above our line or below our line? So those are really the two things that you'll learn today, in addition to what you already know about how to graph a line. So our steps are, first thing, just like we would do for graphing anything, we need to get it into slope-intercept form. Once it's in slope-intercept form, we can figure out our slope and our intercept to graph the line, but we need to decide if our boundary is dotted or solid, and then we'll shade it. So those are really our steps. So starting with number 4, we have a slope, y equals mx plus b. We have no mx, so our slope is 0, and our b, our y-intercept, is 4. Okay, so now we have to make some decisions. We've got the information to graph our line, but we need to decide if our line is going to be a solid line or a dashed line. And the way we do that is we look right here at our inequality. Our inequality is a less than. Our less than means that the line is not included. It would be like an open circle. So it's a dotted line. The information on the line is not included. So we're going to be doing a dotted line, and we're going to be doing it with a 0 slope, which is a flat line, and it's going to be crossing here at the 4. That's our y-intercept. So we're going to do a 0 slope line going across at the 4. Let's go ahead and draw our line real quick. Okay, the last thing that we have to do is to shade our line, to shade either above or below. So right now we look at, again, our inequality. This is a less than. So our less than, we made a dashed or a dotted line, and we're going to shade below. So in order to shade below, we're just going to cover in, woo, that's a big thing, and we're shading below. And there's our solution. Okay, on number 5, it's an x, not a y equation. So we know automatically that we don't have slope-intercept, we have a vertical line. So on this one, we're going to draw our vertical line at the -1. So we're going to draw our vertical line right here at -1. The only thing we have to decide is it going to be a solid line or a dotted line? Well, we have the equal to sign. That means it's included, so it's going to be a solid line drawn at the -1. Okay, vertical lines. We don't have above and below a vertical line. So it's really more like a number line. We're looking at less than or greater than. So less than is to the left side. So we will be doing our shading to the left side. Turn that way down. So we're going to shade everything to the left side of our line. Okay, so number 6, it's a standard linear inequality, nothing vertical, nothing horizontal. So I want you to figure out your slope and your y-intercept, graph your line, decide if it's going to be solid or dotted, and shade it. Pause your video while you do this and then check back for the explanation. Okay, so as soon as you found your slope and your intercept and figured out that it was going to be a dashed line and we were going to shade below, then I just graphed my line and did my shading. Now let's look at these 3 questions at the bottom. So looking at the bottom of number 4, the question it's asking is, can solutions be on the line? So we've got a dashed line. Dashed means it's not included. So no, solutions cannot be on the line. That's the whole definition of a dashed line. Then it asks, is 0, 0 a solution? So I'm going to go ahead and put a point on 0, 0. To be a solution, it has to be in my shaded area, because everything in that shaded area is going to make my inequality true. So 0, 0 is in the shaded area. So yes, it's a solution. Okay, on number 5 is a solid line. So yes, our solutions can be on the solid line. So yes, anything on that line is a solution. Then it asks, is negative 1, 0 a solution? Well, negative 1, 0 is on the line. So yes, it is a solution. And then our final one on number 6, it's asking, can solutions be on the line? Again, the decision is this a solid or a dashed line? It's a dashed line, so the answer to that is nope, cannot be. And then it says, is negative 1, 0 a solution? So I'm going to go out to negative 1, 0, and put a point. Is that point inside my shaded area? No, so it's not a solution.